inside a box. Okay? This is the universe.
Huh.
This empty space. Now, I'm going to start out and put nothing in the universe. So we'll call this like a vacuum. Okay, so I'll write really small here, vacuum. Okay? Now, I'm going to open one end of the universe because I'm going to want to make it bigger. Okay? So let me make this a classic piston. You know what I mean by a piston? So I could slide this in or out. Okay? So if I want to make the universe bigger, I'm going to slide this out. Okay? Now, let's talk about what the vacuum means. Okay? The uncertainty principle says that we cannot be sure about what's going on in any small volume, cubic centimeter, small area of space. And in fact, as a result of that, there's all kinds of virtual particles being created all the time. Okay? These are particles that borrow energy from the vacuum and appear and then annihilate and disappear. Okay? So the vacuum is actually this very lively place of virtual particles appearing and disappearing, appearing and disappearing. Okay? And so there is a certain energy density associated with all these particles. So when I try to open the piston, I'm creating more of these particles, okay? Because I'm creating more possible states for the particles.
Yes.
That means that I have to do work to open the piston, because if I'm going to create energy and I'm going to conserve energy, I have to do work. Therefore, it's very hard to open this piston. In fact, the universe would have this property that we call negative pressure, which means it's the opposite of a gas. If there was a gas in here, it would be positive pressure. It would be hard to compress it. In this case, it acts the opposite of that. It's hard to expand it, okay? And in Einstein's theory of gravity, this weird property of a material that has negative pressure has repulsive gravity, okay? So unlike the cloud of material that would be attractive, right, this exotic stuff called the vacuum, the quantum mechanical vacuum with virtual particles, will have the opposite kind of gravity. It will have repulsive gravity because it has the opposite sign of pressure. And that is according to Einstein's theory of general relativity. And so Einstein's idea of the cosmological constant combined with quantum mechanics says that, in fact, this has to be going on.
Yeah.
How do we get rid of it? How do we stop this from happening? So people would say, I don't know, there's some kind of symmetry, wave their hands and say, it goes away. But nobody had ever measured it. So once we measured it, we said, I guess it doesn't go away. I don't know why it has the value it has. So as I said, we didn't really make anything worse. And at the same time, 3 or 4 other problems in cosmology were solved. And so people, a long answer to your question, people reacted far more positively than I expected.